Welcome everyone. So now we are going to start the class 11 physics chapter motion in a plane topic objective question part 2. So let's begin with me. The first question is the variation of horizontal and vertical distances with time are given by y is equals to 8t minus 4.9 t square, where x is given, which is 60 in mks unit. Then the velocity of projection is 8 meter per second, 6 meter per second, 10 meter per second, or 14 meter per second. Now move with the solution part. Y is given 8t minus 4.9 t square. Now here we are using the projectile motion equation, which is y is equals to u sine theta t minus half gt square. Second equation of a motion here we are using, and as you can see, the motion is in vertical distances. That's why in the place of a u I taken u sine theta. I hope there will be no issue for that. So x is equals to 60 is a given, and after putting this value, like x is equals to the given distance, the variation is a x cos theta, means u cos theta t. So we can say that u cos theta is equals to 6. So u is equals to under root ux square plus uy square. Ux is given u cos theta, which is equals to 6, and uy is given u sin theta is equals to 8. Students, if we do this solution, and so we get the answer, which is a 10 meter per second. According to the option, the correct option for this question is option 3. I hope you understand. Moving ahead with the next question. In the above problem, previous problem, angle of projection is tan inverse 3 by 4, tan inverse 4 by 3, sine inverse 3 by 4, or cos inverse 3 by 4. So students, now move with the solution part. It's a not very tough question. Like you have to simply understand the part of the things. So we know that tan theta is equals to sine theta by cos theta. Sine theta, that means vertical changement in the velocity, and cos theta, horizontal changement in the velocity. So here uy is 8 and ux is 6. After division we get 8 by 6, which means 4 by 3. The correct answer for this question is according to the option is 2. I hope you understand, students. Moving ahead, it was calculated that a shell, when fired from a gun with a certain velocity and at an angle of elevation 5 pi by 36 radian, should strike a given target. In actual practice, it was found that a hill just in one that intervened the trajectory, okay, and the angle of elevation at which the gun should be fired in order to hit the target is, we have an options 5 pi by 36 radian, 7 pi by 36 radian, 11 pi by 36 radian, or 13 pi by 36 radian. So now move with the solution part, students. Theta is given 5 pi by 36 radian. To hit the target, the gun should be aimed at an angle pi by 2 minus 5 pi by 36, which is equals to 36 pi minus 10 pi by 36 into 2, equals to 26 pi by 36 into 2. After solving, we get like 13 pi by 36, according to the option, which is option number 4. So the purpose of this question is simple, that at particular which angle the gun that the bullet hit the target because of the gun. Okay, so this was that angle. Next question, a particle is thrown with the velocity u at an angle theta from the horizontal. Another particle is thrown with the same velocity at an angle theta from the vertical. The ratio of time of flight of the two particles will be tan 2 theta ratio 1, tan cot 2 theta ratio 1, tan theta ratio 1 or cot theta ratio 1. Now moving with the solution part, students. So in the projectile motion, as you can see, we have two diagrams. In this diagrams, there will be two projection angles. One which is made by the horizontal, which is made by the, we can say, horizontal range, and another which is made by the vertical component. So T1 is equals to 2u sine theta by g, we know, and T2 is equals to 2u sine 90 minus theta by g, as you can see from these two diagrams. So here T1 by T2 ratio gives the value of a tan theta. According to this, we have the third option is given correct, like a tan theta ratio 1. Next question is, a ball is thrown with a velocity of u, making an angle theta with the horizontal. Its velocity vector is normal to the initial velocity vector, which is u. After a time interval of u sine theta by g, u by g cos theta, u by g sine theta, or u cos theta by g. Now move with the solution part, students. So here u bar is equals to ux I cap plus u by j cap. From here we can say u cos theta I cap plus u sine theta j cap. So v cap is equals to u cos theta I cap plus u sine theta minus gt j cap. Because the variation is get with the gt also. So vector like u dot vector v is equals to 0. Then u bar and v bar are perpendicular to each other. After solving vector u dot vector v, which is equals to 0, t we get t is equals to u by g sine theta, which is equals to u by g cosec theta, by which we can say the correct option is option 3. Sixth question is, a body is projected with velocity u, making an angle theta with the horizontal. Its velocity when it is perpendicular to the initial velocity vector is u sine theta, u cot theta, u tan theta, u cos theta. So the solution part is like this is the diagram where the horizontal component is a u cos theta of the velocity and a v cos theta means v cos 90 minus theta is the second velocity component. Along horizontal direction, no gravity, hence velocities are equal. So u cos theta is equals to v cos 90 minus theta. From here we can say that like v is equals to u cot theta, which is in option 2. Moving ahead with the next question, a stone is projected from the top of the tower with velocity 20 meter per second, making an angle of elevation of 30 degree with the horizontal. If the total time of flight is 5 seconds and g is equals to 10 meter per second square, then the height of the tower is 75 meter. The maximum height of the stone from the ground is 80 meter. Both the above are true. The height of the tower is 120 meter. So now we'll move with the solution part. As you can see, this is the situation for a horizontal projectile motion. So given that the time of flight t is equals to 5 seconds and g is equals to 10 meter per second. Ux is equals to u cos theta, which is 20 into cos 30. 20 into root 3 by 2, what is the root 3 by 2? It's the value of a cos 30. I hope you understand. So after a division by these two terms, we get 10 root 3. Similarly, we will do with the uy. Okay. So uy is equals to u sine theta. U again 20 and sine theta sine 30. So sine 30 is a 1 by 2. After a little bit solution, we get the value of a uy, which is a 10. Now here we are putting all these values, like h is equals to minus u sine theta t plus half gt square. So after putting all these values, we get the value of h, which is 75 meter. At this particular height, the stone is from the ground. Now h plus h, that is a u square sine square theta by 2g, this value comes 80 meter, which is an option 2. I hope you understand this task, student. If there is any doubt, you may ask in the comment section. Now moving ahead with the next question. 2 seconds after projection, a projectile is moving at 30 degrees above the horizontal. After one more second, it is moving horizontally. Angle of projection is g is equals to 10 meter per second square. First 0 degree, second 45 degree, third 60 degree, and the fourth one is a 90 degree. So moving with the solution part, students, here we have seen, as you can see, like projectile diagram. So we know that tan alpha is equals to u sine theta minus gt divided by u cos theta. For t is equals to 2 seconds, alpha is equals to 30 degree. And tan 30 degree is equals to u sine theta minus 2g divided by u cos theta. Now for alpha is equals to 0 degree, t is equals to 3 seconds. Okay, so 0 is equals to u sine theta minus 3g divided by u cos theta. By solving 1 and 2, we get theta is equals to 60 degree, which is an option third. I hope you understand. Moving ahead. In the above problem, means previous problem, acceleration due to gravity is minus 10 meter per second square, 5 meter per second square, 20 meter per second square, or 2.5 meter per second square. Now move with the solution part, students. So during upward motion, g is equals to minus 10 meter per second square. Hence the correct option is option 1. Next question. The parabolic path of the projectile is represented by y is equals to x by root 3 minus x square by 60. In MKS system, so in MKS unit also, okay, its angle of projection is g is equals to 10 meter per second square. Now we have an option given 13 degree, 45 degree, 60 degree or 90 degree. Now we are moving with the option with the solution part. So solution y is equals to x tan theta minus g by 2u square cos square theta x square. This trajectory of projectile given that y is equals to x by root 3 minus x square by 60. Comparing with y is equals to tan theta times x minus g divided by 2u square cos square theta x square. So tan theta is equals to 1 by root 3. Theta is equals to 30 degree. By which we can say that the correct option for this question is 30 degree. Next question is, a stone of mass m is projected with a velocity u. At an angle 45 degree to the horizontal, its angular momentum about the point of the projection when it is at the highest point. First, mu cube by 4 root 3 times of 4 root 2 times g, mu square by 4g, mu by root 2 or 2 mu cube by g. Now moving with the solution part, as you can see, I'll just throw a body with the velocity u. So theta at that time, theta is equals to 45 degree at the maximum height. So like angular momentum L is equals to r cross p, vector r cross f p or mvr. So L is equals to m times u cos theta h max, m times u cos theta dot u square sin square theta by 2g. This will be mu cos 45 degree u square sin square theta or sin square 45 degree divided by 2g. So L is equals to mu cube by 4 root 2 times of a g, which is the option first. Next question is, a projectile is fired with a speed u at an angle theta. With the horizontal, its speed when its direction of motion makes an angle alpha with the horizontal is u cos theta sec theta, u cos theta sin alpha, u cos theta cos alpha. Solution is u cos theta is equals to v cos alpha. So v is equals to u cos theta divided by cos alpha, which gives the value u cos theta sec alpha. The correct option according to this is second. Next, a projectile has initial the same horizontal velocity as it would be acquired if it had moved from rest with uniform acceleration of 3 meter per second square of 0.5 minute if the maximum height reached by it is 80 meter. Then the angle of projection is at g is equals to 10 meter per second square, tan inverse 3, tan inverse 3 by 2, tan inverse 4 by 9 or sin inverse 4 by 9. So students, for this question, solution is here. So t is equals to given half minute, 30 second, acceleration 3 meter per second square. So ux is equals to u cos theta, which is equals to 80. 3 into 30 is which is equals to 90. We know the formula of a maximum height. H is equals to u square sin square theta by 2g. So h 80 is equals to u sin theta whole square by 2 into 10, which gives the value 80 into 20, which is equals to u sin theta whole square. Means 16 into 100, which gives the value u sin theta. That means 4 into 10 gives the value u sin theta. Tan theta is equals to ux by uy by ux, which is the u sin theta by u cos theta. As you can see, tan theta comes 40 by 90, which is a 4 by 9. And the finally theta comes tan inverse 4 by 9, which is the option 3. I hope you understand students. I did nothing the hard terms. We simply put all these values signed, okay, and keep in this equation u sin theta, and as we know we need the value of a tan theta, so ux and uy, these value I just simply put, and from here I take out the value for theta. Next question we have, if the angle of projection is 60 degree, the height of the projectile when it has traveled a distance 3r by 4, where r is the range, 3 root 3 r by 16, 2 by 3r, root 3r by 16, 4 by 5r. Move with the solution part. Given that theta is equals to 60 degree, so r prime is equals to 3r by 4. R prime tan theta is equals to 4h. R prime tan 60 degree is equals to 4h. H is equals to r prime root 3 by 4. H is equals to root 3 by 4, 3r by 4, or 3 root 3r by 16, which is an option first. Next, a body is projected obliquely with velocity 19.6 meter per second, has its kinetic energy at the maximum height equal to 3 times its potential energy. Since projection from the ground, its position after 1 second is h is equals to maximum height. So first h by 2, second h by 4, third h by 3, fourth h. Solution. At maximum height, kinetic energy is equals to 3 times of potential energy, which is equals to half mu square cos square theta equals to 3 times half mu square sin square theta. Tan square theta is equals to 1 by 3. Tan theta is equals to 1 by root 3 and theta is equals to 30 degree. H is equals to u square sin square theta by 2g. After putting all these value or keeping all these value in this particular equation, I get the value of h, which is a 4.9 meter. From here we can calculate the value of s also, like s is a u sin theta t minus half gt square. So put all these value here again and get the value of a final s, which is a 4.9 meter. Okay, so h is equals to s. What it's mean? Okay, it means simply the distance maximum height covered by an object at 30 degree will be same. Okay, next question is, if 4 seconds be the time in which projectile reach at the P point of its the path, and it will be covered in the 5 seconds, the time from P till it reaches the horizontal plane through the point of projection. The height of P from the horizontal plane is 78.4 meter, 98 meter, 122.5 meter to 20.5 meter. Solution, we have T, capital T is equals to T1 plus T2, which is a 4 plus 5 is equals to 9. So 2u sin theta by g is equals to 9. U sin theta is equals to 9g by 2. Y is equals to u sin theta T1 minus half g T1 square, which is equals to 9g by 2 into 4 minus half g into 16, which is equals to 10g. Or after putting the value of g, which is comes 98 meter. According to this, option is a 2 correct. Next, a shell is fired from a long range gun with an initial velocity u is equals to 1000 meter per second at an angle 30 degree in the horizontal. How long will the shell be in the air? G is equals to 10 meter per second square. 100 second, second 102 second, third 103, 100 root 3 second, and fourth 102 root 2 second. The first option is correct. Now move with the solution part. U is equals to 1000 meter per second. Okay, theta is given 13. So G we know, or also given. We have to calculate like how long it will be. So T is equals to 2U sin theta by G. Put all these value and get the result 100 second. It's an easy question. Okay, now move with the next part, 18. In the above problem, his previous problem, the distance where the shell fall on the ground. So, options are 10,000, 1,732, next 43,300 meter, fourth 86,600 meter. So, correct option is option 4. Now move with the solution part. We know the value of a range. So range is equals to u square sine 2 theta by g. After putting all these value again, we comes the relation this, and after solving we get this formula by this value. Moving ahead with the next question. In the above problem, the maximum height reaches by the shell body. 10,000, 11,200, 12,500, 17,300. Now solution part is h maximum we know u square sin square theta by 2g. After putting all these value we get simple 12,500 meter result. Next question is, if a body is thrown with a vertically of 19.6 meter per second, making an angle 30 degree with the horizontal, then the time of flight is 1 second, 2 second, 2 root 3 second and 5 second. Students, It's again not very hard question. It's a easy. Like we have to apply the time of flight equation, which is 2u sine theta by g. After putting all these values, we get the result 2 seconds. Hope you understand. So students, this is all about for today's class. I hope you enjoyed. If you have any doubt, you please ask in the comment section. Till that, take care everyone. Thank you for watching this video.